Welcome to qnawire.
This is problem number 8 of Stewart, 8th edition, section 2.2. For the function a, whose graph is shown, state the following. So this is the function a, and we begin with part a. What is the limit of this function as x approaches negative 3? And it doesn't specify from the left or the right, so we must look at both. We see that as the function gets closer to negative 3, it increases without bound. That means it approaches an infinite amount. Again, also from the right, we see that the function approaches an infinitely larger number. And since we have an agreement between the left limit and the right limit in that it approaches infinity, we say that the limit as x approaches negative 3 is positive infinity. For part B, now we're looking at x approaching the limit of a as x approaches 2 from the left, positive 2 from the left. So we're looking at positive 2, and we see the function as it gets closer to 2 from the left, approaches a much, very infinitely small number, or infinitely negative number. So from the left, we see that this limit approaches negative infinity. Likewise, at 2, except coming from the right side, we see that the values increase without bound. They get increasingly larger, infinitely larger, and so we say that the limit for part C, as x approaches 2 from the right, is positive infinity. Finally, for part D, the limit of a as x approaches negative 1, we look for negative 1. We see that it is a complete limit, so we have to look for the left limit and the right limit, and then make a conclusion based on that. From the left, approaching negative 1, we see that the numbers get increasingly, infinitely more negative, larger negative numbers. And also from the right, the function approaches negative infinity. And since they both agree, we say this limit is equal to negative infinity. Our last question is regarding the equations of the vertical asymptotes. Usually when functions at certain points along the graph approach infinity or approach negative infinity, they leave this undefined region at these specific x values, and these boundaries we denote as asymptotes, and they are vertical asymptotes. And the way that you write the equation of a vertical asymptote or a vertical line is in the form x equals a. This is the format where a is the location of the asymptote. So we locate the asymptotes, we locate the boundaries that the function never reaches. Here we see there's one at negative 3. Then we follow along, we see another boundary at negative 1. And then finally the last boundary is at positive 2. Therefore, the equations of all the asymptotes are negative 3, negative 1, and positive 2.